everyone, and welcome to another lesson. Today we are working on section 4.5, and that focuses on dilations. Today we are just going to look at the dilations on a coordinate plane. And in order to start studying that, we have to understand exactly what a dilation is. And as you can see from this definition, it is a transformation in which a figure is enlarged or reduced with respect to a fixed point. So essentially, I have this example here, we're zooming in or out of a picture. That's the idea of a dilation. Then there's two things you need to understand with dilations, and that is the center of dilation, which is a fixed point in a dilation, and that's the point we're going to actually dilate about. And I'll show you what I mean by that in just a minute. And then scale factor is how big or small we are going from the original image to the final image, or from the pre-image to the final image. The actual definition for that is the ratio of the lengths of the corresponding sides of the image and the pre-image of a dilation. Within a dilation, the angle measures are preserved, so the side lengths will change, but the angles remain the same. Let's do some examples here. We'll take a look at these two examples. So we want to find the scale factors of these dilations and then tell if it's a reduction or an enlargement. Are we making the image bigger or are we making it smaller? One thing you need to know when we are looking at scale factors, the scale factor again is abbreviated with the letter K. You're actually going to look at the ratio of your final image to your pre-image. In this case, P prime is our final image and P is our original. The pre-image is CP and the final image is CP prime. In the numerator, we want CP prime over CP, so we want that ratio. The ratio from C to C prime, the length from C to C prime is 4, and the length from C to P is 12. We need to reduce that down. You can take a 4 out of all of this, so this turns into 1/3 or 1/3. So you have a ratio of 1:3 here. And if you take a look at the blue triangle to the red triangle, this one starts out larger than this one, so this is a reduction. We are making the image smaller than the pre-image. Following this exact same concept for part B, we are going to go from the blue line to the red line. So in this case, we can see our blue line is shorter than our red line, so we're going to do an enlargement here. And we need to look at C to P prime over CP. So C to P prime has a length of 25, and the length of CP is 10. Reduce this down and we have a scale factor of 2.5, and as we had said just a moment ago, this is an enlargement. You'll notice here that when we were zooming in or working with an enlargement, we have a bigger number and we have a smaller number for our reduction. And this smaller number is actually a fraction. It's less than 1, and this one is greater than 1. And this is a rule that holds true for all reductions and enlargements. If we have a scale factor that is between 0 and 1, we have a reduction. And if we have a scale factor that is greater than 1, we will have an enlargement. So by looking at this ratio here, you can quickly tell just by the value whether or not you have an enlargement or a reduction. I have another example for you guys. And this one, if you think about when you're typing up a paper and you change the font, you're either making your font larger or you're making it smaller. You can figure out the scale factor based on how big you are making it. Scale factors for font are actually in pixels. We're going to look at it in terms of inches though. So we are working with an original or a pre-image that has a height of a 1/2 inch, and we want to change it so that it's 1.25 inches tall. Just to give you a visual of what we're talking about here, we're going from this small a to this large A, obviously not drawing the scale because I just drew it by hand. And if we take a look at our previous formula for our scale factor, it's your final image, the size of your final image, or that distance divided by the pre-image. We have 1.25 divided by 0.5, and this works out to be 2.5. So we have an enlargement because it's greater than 1. Next, we're going to look at dilations on coordinate points. So the coordinate rule for dilation says if we have some point P and it's the pre-image of a point, then its image after a dilation centered at the origin, 0, 0, with the scale factor of k is the point P prime. And in order to figure out that P prime, you take that scale factor and you multiply it by the original x value from your original point and the original y value from that original point, and you'll get your P prime. Let me graph this really quick for you. I graphed this triangle PQR, and we're at the point of P, which is 0, 2, Q, which is 1, 0, and R, which is 2, 2. And it's asking us to make these dilations with a scale factor of 3, 1/2, and -1/2. If we follow this rule up here, what we're going to do is we are going to take 3, since that's our scale factor for part A is 3. We're going to take the 0 and multiply it by 3, and we're going to take 2 and multiply it by 3, and that will give us our new P prime. So we will have 0, 6 as P prime. We're going to do the same thing with our Q, X, and Y values. So 1 times 3 and 0 times 3 will give us our Q prime of 3, 0. And then R prime multiplied 2 times 3 and again 2 times 3. We get the point R prime, which is at 6, 6. So now we want to plot those. I'll plot those in green for us so we can see a little bit of a difference here in what's going on. P prime is at 0, 6, so to the right 0, up 6. Be sure to label your points. Q is at 3, 0, and R prime is 6, 6, to the right 6, up 6. Connect your points. And we have this green triangle as a enlargement with a dilation, and we have this green triangle that is a dilation with a scale factor of 3. Since 3 is greater than 1, it's an enlargement, and you can easily see that we went from this smaller gray triangle to the bigger green triangle. Let's do the same process for part B, and here we're going to multiply by a scale factor of 1/2. So following the same process of multiplying our x and y values by 1/2, I'm going to go ahead and pause this and write that out, and then I will graph this for you in just a second. I went ahead and multiplied all of our points by the scale factor of 1/2. We end up with P double prime is over 0, up 1. Mark that P double prime. Q double prime is to the right 1/2, up 0. And then R double prime is to the right 1, up 1. Orange here is part B. And then the last part, part C, we're working with a -1/2. So you're going to do the exact same calculations, except you have a negative in there. And I already worked those out so that we can just plot them on our coordinate system. And so we have -1/2 times 0 and -1/2 times 2 gives us a P triple prime, right or left, 0 down 1, P triple prime. To the left, 1/2, up 0 is our Q triple prime. And then R is to the left 1, down 1, R triple prime. And we will connect those points. And this is part C. So if you take a look at part C, we know it is a reduction because it's less than 1, but the negative indicates that we are actually going to flip this. Last thing we're going to look at is just the difference between a rigid and non-rigid transformation. So we keep saying rigid, and rigid means that we're not changing the angles or the side lengths. For non-rigid, that doesn't hold true. So if you take a look at this horizontal stretch, horizontals to the left and right, we essentially take this blue triangle ABC and we pull point B out to the right, and we end up with triangle A, B prime, C. And since these side lengths are not preserved, this is a non-rigid transformation. Same thing with this angle B. B prime and B will not be congruent. If you look at this triangle ABC in the blue here, and we lift A in the vertical direction, if we lift it up, we're stretching that left side here, the vertical side length of AC to A prime C. So you can see that's longer. You'll be able to see that this leg is much longer. So we are not preserving side lengths or angle measures in here. So that concludes the first half of our lesson in section 4.5 on dilations. So you learned about the calculation on how to figure out the scale factor. We did some of those examples, and then we worked on plotting those, figuring out the scale factor and plotting them on a coordinate system. The next lesson we're actually going to learn how to construct a dilation. So if you're interested in that, I will see you on part 2. Thank you.